Dear students, today we will learn about Heisenberg's uncertainty principle. This is also known as principle of indeterminacy because uncertainty and indeterminacy are implied from one another. What does it mean? In classical physics, a moving object has a definite momentum associated with it, and its position in space can also be determined to a good degree of accuracy. But as the size of the object under consideration falls down, especially to atomic dimensions, then there is an uncertainty with regard to measurement of different parameters associated with such particles, such as their position, their momentum, their velocity. So, how do we understand that? If, for instance, you want to locate the position of an electron, this is the microscope which you are placing above it to look at it. But in order to make it visible, at first you have to make incident some light on it. Even if a single gamma ray photon is incident on the electron, it is sufficient to displace it from its position. You understand that? And even if that displacement doesn't happen, but because of Compton effect, this electron will show a recoil, and we understand that this electron will be found somewhere in this cone of illumination. In this cone of illumination. Therefore, incidence of this photon on this electron has imparted an uncertainty to its position. If instead of this electron there were a huge object at its place, incidence of even too many photons would not have changed its position or its velocity. But these things do happen once we approach the subatomic domain. In addition to that, this electron was moving with some velocity, with some momentum before the incidence of this photon. But after the incidence of this photon, that momentum and velocity has also changed. Now, how do we write that? We write that the product of uncertainty in position and uncertainty in momentum is greater or equal to h cross. And this is known as Heisenberg's uncertainty principle. In words, we can put it as it is not possible to determine with entire certainty or accuracy the position as well as the momentum of a small moving particle like electron. Now the question is, how do we understand this and how do we arrive at this result? Imagine the diffraction of electrons through a slit, right? This is the original direction of incidence of electrons which hits the screen. But if this slit is a narrow one, this electron beam undergoes diffraction. Therefore, at the edges, it also traverses the paths which are inclined to the original path at a certain angle, say theta. Let delta y be the width of the slit, right? So from the principle of diffraction, we know that 2d sine theta is equal to n lambda. For 2d, we can write here delta y. Let these be the two planes. Distance between them is 2d sine theta. So delta y is sine theta is equal to, for the first order, this will be only lambda because n is 1. So delta y is equal to lambda by sine theta. Now before the diffraction, when this electron beam was traveling straight and hitting the screen, it had only one component of momentum, and that is px. But after diffraction, we understand that even the momentum has been assigned an uncertainty. And now the momentum has also a y component, py. And that py is obviously p sine theta. So the total uncertainty in momentum is delta py, which is equal to p sine theta in the upward direction minus p sine theta in the downward direction, and that is 2p sine theta. Now all we are interested in is to find this product, delta x and delta p. So we write that as delta y into delta p is equal to rather py, delta py, because this is the component of momentum in the y direction. Now for delta y we write lambda by sine theta, and for delta py we write 2p sine theta. Again, by using the concept of de Broglie waves, for p we can substitute h by lambda sine theta. So the sine theta and sine theta will go, lambda and lambda will go, we are left with 2h only, right? This means that this product delta y delta py is equal to 2h, or in other words it means it is greater than anything which is less than h. So that can be h by 2 pi or greater or equal to h cross by 2, or h cross only. H cross only doesn't matter. Finally, we extend this uncertainty principle to all such pairs of quantities whose products have the dimensions of action. By action, I mean whose units are joules second. And these include the quantities like delta theta, delta p theta is greater or equal to h cross. All we have done is replaced x by angular displacement and linear momentum by angular momentum. That is also equal to greater or equal to h cross. Similarly, energy time uncertainty, delta E, delta T is also greater or equal to h cross. Remember, in quantum mechanics, every particle is associated with a wave packet. Wave packet. There is not a definite x, y, and z assigned to a particle, but rather a wave packet or a spread in space within which it can be found. Smaller the size of the wave packet, smaller is the uncertainty in position, but larger is the uncertainty in velocity. Larger the size of the wave packet associated with the particle, larger is the uncertainty in position, but smaller is the uncertainty in its velocity or momentum. We'll also try to improve on this understanding by doing some further examples, but that will be taken up in the next video.